Hello everyone. In today's lecture, we will start the unit number 5, that is the transient state stability part 2. In that unit, the different content related to transient state stability are number 1, type of faults, second, grounding and high speed reclosing effect that we have to discuss, then the pre-calculated swing curves and their uses, as we already discussed the swing curves in the previous unit, and fault clearing time, what is the fault clearing time and why it is important while dealing with the transient state stability. Then the excitation and the governor action effect on the transient state stability, and steady trust stability improvements methods related with the transient state stability, that is very much important with reference to unit number 5 that we have to discuss. And the multi-machine problem and the network analyzer and the digital control computer role, this is also the content in the unit number 5. So let us discuss the one by one all the content of the unit number 5. First we concentrate on the grounding and the high speed reclosing effect. What is that about the grounding and how that directly affect the transient state stability under the different infinite burst systems. Okay, so basically the grounding effect is the depend what the generally useful to modify the its zero sequence impedance. Means what to improve the power zero sequence impedance of that power system. If you have to not improve the zero sequence, it should directly affect the fault clearance, that is the fault that will occur on the power system, that should directly affect it if we not modify the impedance of that zero sequence impedance. As we all know, there is a the three impedance are there. First is the positive sequence, second is the negative sequence, and third is the zero sequence impedance. Okay, so the grounding effect are generally useful to modify that zero sequence impedance to overcome its fault occur on that power system. Okay, so this affect the power impedance of that fault shunt, that is the shunt fault, generally for the representing the ground fault, and thereby it's thereby affected by the severity of the such fault. Okay, so if you have to not, it should directly affect the impedance of that shunt fault or the grounding fault. Therefore, their importance is very much important, very much essential to while modifying the power system. Okay, so the most of the transmission system are generally grounded through the transformer or through the LA or through the different approaches. But basically, the transformer is not even grounded at a high voltage winding, which are generally connected in the delta, that is not even to start with the grounded neutral. Okay, so the transmission system to which the generator should be connected are generally than the transformer are grounded to the generator. Means what? Transmission system are generally grounded with reference to the with the help of the generator by grounding through the generator, and the generator neutral, like the transformer neutral, may be the grounded through the resistance or the reactor. So that resistance, reactors, or the impedance are generally useful to ground the different apparatus of that power system, so that to overcome or to modify its zero sequence impedance, so that to overcome the severity of that different fault occur on that power system. Okay, so to improve the zero sequence impedance from the point of the fault, result in the decrease the, obviously the severity of that fault should be the decrease from the line to ground below, या फिर two line to ground below, या फिर unsymmetrical or the symmetrical fault के लिए. Okay, so this effect on that system stability during the ground fault is better than the solid grounding. Okay, so either the resistance or the reactor are generally used to decrease the severity, but the reactor are generally cheaper as compared to the resistor, and the resistor also has some limitation as compared to the reactor. Okay, so the different apparatus like the transformer, generators, or the transmission line are should be the grounded to overcome the or to modify the zero sequence impedance, and that to improve the zero sequence impedance, it should directly amplify the decrease the severity of that ground fault, which is more essential to improve the stability of that system, that is the power system. Okay, so the system generally consists of that several synchronous machine, which are generally connected to the infinite bus. That occur the occurrence of that fault generally decrease the uh, electrical output of that generator, and therefore the electrical input of that causing the generator to oscillate, and the motor should be the retarded. Means what? Whenever there is there's the so many synchronous motors should be connected in the parallel or on the infinite bus. If the fault occur, obviously the output of the electrical output should be directly affected. If the electrical output should be directly affected, electrical input should be the affected, and causing the generator to accelerate more and more, and it causes the motor should be the retarded. Okay, thus the stability generally promoted or to be improved by increasing the output और लेसिंग द एक्सेलरेशन इंक्रीजिंग द आउटपुट कर लो या फिर लेसिंग द एक्सेलरेशन करो प्रोवाइडेड दैट रिटार्डेशन ऑफ द इट्स नॉट इंक्रीज करस्पॉन्डिंगली इन शॉर्ट तो stability should be the promoted or stability should be improved while keeping the synchronization between the different synchronous motor. Okay, so thus the grounding resistors by consuming the power through the ground fault should be the exert on the synchronous motion to affect the braking effect, which is generally greater, and the lesser it should be the it should be the closer to the fault to the resistor, and the closer to the machinist to the fault. So the grounding resistors, reactors are generally useful to amplify or to implicate the grounding effect or to implicate the grounding effect to lower down the severity of that fault on the different apparatus of that power system to improve the stability of that power system. Okay, so this is the grounding effect. Generally, the choice of grounding generally depend upon the different factors. Number one, limitation of that current. Second, damage to the generator with the excessive mechanical forces. Second, limitation to the neutral to the ground. Line to ground voltage, उसका voltage कितना रहेगा to permit the useful grounding insulation. And lighting arrestor का rating कितना है of that lower voltage rating, which is give the better protection. Okay, so, and the limitation of that inductive inclusive or communication circuit through the grounding fault of that power system, it should be directly affect the grounding effect occur on that transmission line. Okay, obtaining the suitable condition from the rapid and the selective relay operation to the clear the ground fault. It is more uh, better solution as compared to the grounding. Okay, since the condition of that limiting the current with out of this layer above, because to limit the fault current there is a several solutions are there. Out of them the grounding is one of the solution is that, but better than the grounding such as relay operation, even the communication circuit, or even the voltage transformer or the graded insulation should be used, or the lightning arrestor should be used. That is to the more better solution as compared to the grounding effect. Thus, the condition of that limiting the current with those of the limiting voltage, the choice of grounding is stressed to the compromise. Okay, thus the importance of the effect on the stability of the method of the grounding should be decreased in the resistance here by the thread towards the high speed of that fault plane. So basically, the grounding technique are generally preferable previously, but in the current condition, the more better solutions to lower down the fault clearing, to minimize the fault clearing time should be there to improve the stability of that power system. The grounding effect are generally implemented by using the grounding resistors, reactors, and the main board, but by using the relay operation, auto reclosing, or the relay operation, or the voltage transformation, that is nothing but the lighting arrestors, it gives the more better solution to lower down the severity of that fault, which give the more better solution as compared to the grounding. Okay, so that's why that importance of that grounding, it generally lower down in the current years. Okay, uh, now the effect of that high speed reclosing on that stability. First is that about the grounding effect. Second is that about the, now we will discuss the high speed reclosing on that stability. Okay, so with respect to the effect of that stability, that is that about the high speed reclosing on that stability. What is that? It is that about the reclosing high speed. How fast we reclose the whenever there is a fault should be occur on the transmission line, uh, because of any unwanted reasons, it should be the reclose, or it should be that fault should be the automatically clear. If it is not clear, we have to clear it manually. So how fast we have to clear that fault, and how fast that the reclosing of that circuit breaker should be occurred, it should directly affect the stability of that system. Okay, that's why the generally when during the extra high voltage transmission line, it transmit a very high current electrical power. That's why the continuation of that power flow, it should not be the interrupted for the long time, because it should, if you have to interrupted the EHV line for the long time, it should directly affect the whole system should be the blackout condition. Thereby, the temporary and the fault line, there may be the temporary or the permanent fault on the system should be there, but that fault should be clear as soon as possible. The temporary fault is what just get automatically clear, like the touching of the trees to the transmission line or the overhead due to the lightning is there is not even a temporary fault are there. Okay, thus does not require any attempt to, because it should be the automatically cleared within the particular second. Does not require any fault clarification, rectification, the human interfere in that. In the normal practice by the operator that after the each initial faulty tripping of the line, they should close the line. Means what? Means what? Whenever there is a fault should be occur, that temporary fault should be the occur on the transmission line. The fault, transmission line should be the trip out for the particular second, and it should be the clear out after the particular. It should be the automatically clear out. That should is not even the temporary fault is there. But if the fault should be occurred for the more time, that is not even the permanent fault will occur होल्ड आफ्टर द सेकंड अटेम्प्ट ऑफ दैट रिक्लोजिंग ऑफ दैट ब्रेकर मींस व्हाट ऑपरेटर क्या करेगा एक बार उसको ऑपरेट करेगा दैट इज नॉट इफ द फॉल्ट शुड बी ऑकर एक बार उसको फिर से रिक्लोज करने की कोशिश करेगा इफ इट इज रिक्लोज देन इट्स नॉट द टेम्परेरी फॉल्ट इफ द फॉल्ट शुड बी द ट्रांसिस operate second attempt by the closing the circuit breaker should be occur, but if the fault purpose the protection system again the trick the line and this is declared is ready but the permanent fault किसको बोलेंगे अगर whenever we have to uh, provide the two attempts to close the circuit breaker, and if the but the if, even if that close the circuit breaker we gives is nothing but a trip signal from the trip the line, then it is declared is nothing but the permanent fault should be occur on that transmission line. But as the extra high voltage transmission line is there, huge power declare delay should be occur manual operation, should the big loss to the system in view of the cost also, in which of the mm, in which of the stability also. Okay, thus by enclosing the auto reclosing scheme kya hai, it is able to automatically whenever the fault should be occur, the circuit breaker should be clear its fault automatically in the extra high voltage transmission line, so that to avoid the unwanted delays due to the human operation, to overcome the cost and the stability. Okay, so this is that what it directly implicate the stability of that system. If the delay should not be there, ऑटो रिक्लोजिंग हो रहा है तो टाइम कम लगेगा, फॉल्ट क्लियरिंग टाइम कम रहेगा, जितना कम फॉल्ट क्लियरिंग टाइम इट शुड डायरेक्टली अफेक्ट द स्टडी बट द स्टेबिलिटी ऑफ दैट सिस्टम, इट शुड improve the stability of that system. Okay, this is nothing but the different auto reclosing systems are there. For that case, EHV bus bar reverse is there, that is nothing but the auto reclosing, that is a automatic AVR system is there. Now we can categorize the fault into the two systems. First is nothing but the transient fault, second is nothing but the semi-permanent fault, and third is nothing but the permanent fault. Transient fault क्या था? It's nothing but the temporary fault. Automatically remove the momentary. Okay. Semi-permanent fault क्या रहेगा? It takes the few minutes to remove after due to falling of that some of the falling of the things on the live conductor. Like this nothing but the tree should or the branches of the tree should be occurred fall on the transmission line, that is called as semi-permanent fault. Semi-permanent fault how can you improve? After the causing the fault is to be the burn away. तो जो भी उसपे fall हुआ it should be the burn out. After that that semi-permanent fault should be the clear. During the both of the above mentioned fault, line is strict, but the line can be the restored if the circuit breaker associated with the line are the closed. Means what? We have to trick that, we have to reclose the circuit breaker after the particular time, that called a semi-permanent fault and a transient fault. But in the overhead transmission line, 80% of the fault is studied but the transient, and removing 12% fault is studied but the semi-permanent. That is studied but the some of the unwanted things are generally fallen on that transmission line. Okay, so in that case, the auto reclosing schemes, it generally not clear the first attempt, and the doubles or the triple short of that reclosing until the fault should be the clear should be the occur. If the fault still permits, if we have to do the trip signal to that closing or reclosing of that circuit breaker, then it's called as that is studied but the permanent fault. Thus the fault still permit, then call is studied but the permanent fault. Thus the transient stability is very much affected. The auto reclosing should not be properly incorporated. Okay, so this is all about the auto reclosing, effect of the auto reclosing, and that effect of the grounding of that transmission line. Thank you so much. In the next lecture, we'll discuss another new concept with respect to the transient state stability.